Hello guys, I'm Olafem tutor, your tutor, your dynamic air tutor. So here I'm using this interactive simulation to demonstrate factors affecting parallel plates capacitor. O-level physics, A-level physics, even university physics. So talking about the factors affecting the parallel plate uh, capacitor. Now we have two types. We have two plates. The positive plates, you can see the cursor here, the cursor that I'm shaking here, and then we have the negative. Abi, right? We have the negative. So now, what I want to demonstrate is just as simple to show you that capacitor stores charges, and what are those factors that affect the storing, okay, that is storing of these charges. So we have about three factors that affect uh, the capacitance of the parallel plate capacitor. Moreover, what is capacitance? As we all know that capacitor is a device that stores electrical charges. So capacitance is the ability for a capacitor uh, to store charge per unit potential difference. So, and this is the battery that we'll be using, right? So, we have the 1.4 volts. So, and this is the ground, the zero level. So, which is also as negative. This is a positive. So, in case you want to change the polarity, the plate interswitch. All right, the plate interswitch. As it is now, the capacitor is charged. Okay, and moreover, if you look at the 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 direction of the current flows from the positive to the negative. So in this case, it flows for the negative, positive to the negative. While the for the direction of the electrons, we all know that electron moves from the negative to the positive. Look at this arrow, the blue arrow, at this here, this bottom, yeah. So it moves from the negative to positive. In case I change it, I switch the this polarity. I'm going to change the plate. So this is the negative. So the negative, the electron will flow from the negative side of here, then to the positive. So why the current flows from the negative, from the same from the positive still to the negative. Okay, so here we are using a voltmeter. This is a voltmeter. So the voltmeter is connected to the one end of the terminal of the capacitor, and the negative terminal, the black probe, is connected to the uh, another end of the capacitor. Let me change it to the to this side. Okay, to this side. So 1.5 volts positive. So to this side. Okay, so now what we want to do is to, you can see that the reading has already shown 1.5 volts. That is, this is the voltage, the potential difference across this battery, and as the potential difference across the battery, entering the capacitor here. So the capacitor here is already charged here. So now we have three factors that affect the capacitance of the capacitor, of a parallel plate capacitor. Number one, we have the separation of the plate, that is the distance between the plates. We have the plate area of the plate, how bigger, how wide it is, just like comparing it with your tank. So the larger the tank, the larger the water, that's the larger it stores. All right. So separation has to do with that is inversely. I'm going to show you the later on the formula that connects all those quantities together. So now the last one is the dielectric. That is the nature of the materials uh, of the plates. So for example, we have glass, we have ceramic, and we have paper, different like that. So it also affects the capacitance, that is the ability of a capacitor to store charges. So now let's go. So looking at this uh, two plates, you can see the distance here. That is the farthest distance. Okay, you can adjust it with this farthest distance. So let's set it at 10 millimeter, 10 millimeter. So after this, we will now connect this capacitor with the terminal of the bulb here. Okay, the terminal of the bulb here. So by connecting it, let's see what will happen. We believe that the bulb will light up, but it's not going to die off immediately, because some certain amount of charges are being stored. So let's see how it is. Wow, let's try it again. We can see it now. Can see it now. So now let's now reduce this distance, this plate. Okay, let's reduce the distance and see the effect after after the capacitor is being charged there. Can you see now? Can you see the time it takes for the bulb to light off? Let's do it again. You can see now. All right. So this one is telling you that the closer the distance, the smaller the distance, the more the charge that is being charges stored in the capacitor. So what is telling you that the farther the distance, okay, the lesser the amount of charge stored, and then while the closer the distance between the parallel plates, the more the charges are being stored in the capacitor. So that is it for the case of separation between the two plates. Now let's go for the area of the plates. So you can see that the least area here we have here, looking at this figure, is 100 millimeter square. So while the highest value here is 400 millimeter. So let's look at the least value here, considering the least value here first, and see the reaction on the bulb here, just like when we have before, right? Now let's now increase these parallel plates. Okay, let's increase it to the highest, at least to the largest value. So, and let's see the how it would be. Let's see. Wow, wow. Let's see once again. So you can see that the wider the area of the plate, the more the more charges are being stored. Okay, thereby thereby increase the capacitance of the capacitor. So the wider plate, more charge is being more charges are being stored. That is more capacitance. That is, capacitance here is directly proportional to the area of the plates, between the two plates. So that is what is telling us here. So the last one, which is not here probably showed here, is uh the dielectric, the nature of the materials in the plates. As I told you, that is permittivity. So this one talks about it is always it affects the effective of the electric field, thereby it enables capacitor to store more charges. So in other words, higher permittivity results to increasing capacitance. That is, when there is the presence of these materials, nature of these materials in the plate being inserted, it enables the capacitor to store more charges. Okay, to store more charges. So let me quickly move to um, the aspect of the which I will like to show you on the okay. I'm called okay. Yeah. So if you look at this now, factors affecting the capacitors of the capacitance of the parallel plates, distance between between the plates, area of the plate, nature between the nature of the materials. Okay, the nature of the materials between the plates, the nature of the materials. So this place will be materials. Don't mind the way I write materials between the plates. That is dielectric, paper, glass, or ceramic. So if you look at considering this, the formula that connects them together. This is the capacitance, ability to store charge per unit volt potential difference, is equal to the dielectric multiplied by the area of the plates over separation between the plates. That is distance between the plates. So mathematically, what it's saying is that C capacitance is directly proportional to the dielectric. The higher the dielectric, the permittivity, the higher the more the charge stored in the capacitor. So here looking at this one, here capacitance is directly proportional to the area of the plate. That is, the larger the area or the wider the plate of the area, the more the charge or charges stored in it. All right, and considering here inversely proportional to distance between the plates. So what this place is telling us that the the closer the plates, the more the capacitance, while the fairer the plate, the lesser the capacitance. So that is it. So and where can we this this capacitance capacitor be useful? It can be useful in the radio circuits, that is tuning circuit system, radio television, in order to obtain our radio station, FM, AM, frequency modulation, amplitude modulation. So, and also it can be useful, it find its usefulness in a car ignition system, okay, and also in a camera flash, all right, in power supplies, then touch screen. So I think from here, I'll be able to show you, to show you what how this these factors affect the capacitance of the capacitors. So if you have any question to ask, you are feel free to ask, comment, and share. Share your own idea. Thank you.